We begin our Python exploration with variables. Uh, in many programming languages, virtually all programming languages, uh, we have variables. Now, unlike many programming languages where variables, they are like boxes used to store values. So in many programming languages, variables, they're like boxes or buckets that store data or values. Now, in Python, variables, they are not boxes used to store values. In Python, variables, they are pointers. So in Python, we use variables to point to boxes, buckets containing data or values. Okay? So in Python programming, variables do not store values. Variables point to objects, and objects, they're like buckets of data. Objects, they're like buckets holding values, if that makes sense. Okay, so I'm going to start my terminal now, and then we're going to explore some of these uh, concepts. So let me type terminal here. I'm going to zoom this in so that you can see what I'm doing. Um, okay. If you watch the previous tutorial where we explore some of the different options available to us for installing Python, you would have seen how we set up what I'm about to do now. So uh, in the previous tutorial where we set up our Python, we say for us to to work with Python in the terminal, we have two options available. We can type Python using the Python interpreter. So if you open your terminal now, it doesn't matter whether you're on Mac OS, you're on Windows, or even on Linux. Once you have your Python installed, you should be good to go. So here we can boot up the Python interpreter by typing Python and then we press enter. This is going to bring up our Python interpreter. Good. And sure enough, we can play with some Python code here. 2 plus 2, this gives us 4. Okay, we can do type 4, this gives us int. Okay, but then there is another option available to us aside this Python interpreter. Uh, okay, so what I'm going to do is I'm going to exit out of this and then I'm going to boot up the other option. And the reason I'm going to try to use that other option is because I think the other option has better graphics compared to this native Python interpreter. So let me zoom this in even further. So I'm going to exit out of this. This is how we exit out of Python interpreter. Okay, so I'm going to clear. Okay, so I'm going to boot up Python. No, I'm going to boot up IPython interpreter. Okay. Uh, if you don't know how this is set up, you can watch the setup tutorial that we did prior to this one. So this is IPython. I'm going to press enter and then it should bring up its own interpreter or shell if you like. Okay, so you see this has a better graphics compared to the other one in my view anyway. Okay, so let's start up our exploration of Python variables. We're going to talk about Python variables here, In the next tutorial, we're going to talk about the different Python types. Okay, so if I start with, if I say x is equals to 10, okay, and then I say hex, okay, I'm getting 10. Good. If I say y is equals to x, okay, and then I say y, of course, I could have done print y. I still get the same thing. Okay, good. Oh, let me print hex. We get 10. Now, I want you to pay attention to what is going on here. We are using the assignment operator, this equals to sign, to assign value 10 to x. Okay, good. I can use the word assign. So what that means in Python speak is we are pointing x to these 10 objects. Okay? In Python, we do not declare variables because variables are pointers. They point to some data location. They point to objects. So when we say x is equals to 10, what we are doing is we are pointing this variable x to this object 10. Okay. Now, at this point, when we say x, y is equals to x here on line 3, when we say y is equals to x, what we are doing is we are pointing y to the object that we pointed x to begin with. Okay? So y is pointing to the 10 objects that x is pointing to. So now at this point, x and y, they both point to object 10. Okay? X and y, they both point to object 10. Okay? Now, look at this. If I do x plus 2, no, x plus equals to 2. Okay? And I say print x, I get 12. Now, if I say print y, I get 10. Now, you see what is going on here. Initially, x and y, they were both pointing to the same bucket holding a value 10. Okay? Now, when I get to this point, when I say x plus equals to 2, what I'm doing is I'm not modifying x per se. That's not what I'm doing. What I'm doing is I'm modifying, no, what I'm doing is I went from x pointing to 10, okay? Because integer is immutable. We cannot change their internal state, okay? So I don't want you to get this confused. So what I'm doing now is I'm reassigning x, okay? So these two objects that x is pointing to, okay? These two objects that x is pointing to here, okay? And here, x, before now, x was pointing to 10 objects, okay? So now x is pointing to 2 objects, the 10 objects before now, and now x is, so when we say, okay, let me print x, now x is 12. Now x is pointing to object 12. So what happened was I had modified the objects that x was pointing to. So here we have 2 objects, okay? And then the 10 objects previously, prior to this time. So we now say x is now pointing to object 12. Now, because I didn't use equals to reassign y. Y is still pointing to object 10. It was y, they were different. And this is good for arithmetic operation. So that because integer, here we're using integer, which is immutable. We cannot modify the internal state. Okay? So if it turned out that as we modify the object that x was pointing to, y is being modified as well, this is going to have some kind of bizarre implication for our arithmetic operation. Okay? So I want you to have this at the back of your mind that here I'm not modifying the variable x. What I'm doing here is I'm modifying the objects that x is pointing to. Okay? So that was why before x was pointing to 10. I modified that object 10 with this plus equals to 2. Okay? Now x is pointing to object 12, the modified objects. Okay? And this is still consistent with the idea that simple types in Python, they are not mutable. For if they were to be mutable, then what we did here would also affect the value of, would also affect the object that y was pointing to. So it didn't affect the object that y was pointing to. Okay? Now, if we try to do the same for mutable type, let's see what we get. If I do a equals to 1, 2, 3. Okay, so this is a list. Okay? And then I say b equals to a. Okay? If I say print a, see what we get. Okay? Sure enough, we get a list. If I say print b, we get the same list because we are pointing b to the same object that a is pointing to. Now, list is mutable type in Python. Pay attention. Python objects, they do have attributes and methods. So because of that, I can do this. A dot, if we want to add new item, new elements to a list objects in Python, we use the method append. Okay, so if I say a dot append 4, for instance, and then now I say print a 1, 2, 3, 4. Now watch this. If I say print y, oh sorry, print a, I said printing y. I wanted to print b, print b. Remember, we pointed b to the same object that a is pointing to. Now check this out. See, when we modified a, we didn't modify a. I'm sorry. When we modify the object that a was pointing to, because we pointed b to the same object as a, modifying the object that a was pointing to also modified what b was pointing to. And the reason why this is happening is because the object that a is pointing to is list, and list is mutable. So when we say mutable, what we're saying is we can modify, we can change the internal state of such an object. Let me take that again. When we say mutable type in Python, what we mean is we can mutate, we can change the internal state of that object. Okay? So in Python, when we point two variables to the same object, if the object is immutable, okay, we can reassign, if we reassign one of the variables, it only affects one. If we point two variables to the same object and that object is mutable, if we mutate one, it affects the other, just as we have seen here. Okay? Now, in Python, we can do this. We have the luxury of doing this. We can do var equals 2.5, for instance. And it's sure enough, if I do var, I get 2.5. That's the output. Okay? I can also do var equals to high. And now if I do var, I get high. I can also do var equals, we've been working with list. Let me stick with list. 1, 2. And then when I say var, I get 1, 2. Now what is happening here? Remember we said Python variables, they are not buckets that hold data. Python variables, they are not boxes, they are not buckets for storing data. Instead, Python variables are pointers. Python variables, they point to objects. So we went from var pointing to a float 2.5, this float object, okay? And then we went ahead and point var to another object, string object high. We still went ahead to point var to another object, list. So this is what is meant when they say Python is dynamically typed. Python is dynamically typed. So we can point in Python, we point variables around objects. Okay? We point variables to different objects. Okay? So we went from pointing var to 2.5, and now we point var to high. It's still pointing var to to this list. Okay? So this is still consistent with the idea that in Python, variables, they do not store values. What they do instead is they point to values. They point to objects. Okay? They point to object location in memory. Is why we can take variables and point them around different objects as we like. Okay. Now, when we say object, what are we talking about? In every programming language, in object-oriented programming language, especially, objects hold some kind of data. And this data, they have some kind of information known as metadata. Okay? And this metadata, they could be attributes and methods. Okay? So the objects hold data. Okay? And this data have some kind of metadata. Metadata is it just gives us more information about the data that is contained in our objects. So in our object, we could have attributes, we could have methods. Methods are like functions inside objects. Okay? Now, you may have heard that in Python, everything is objects. That makes sense. In Python, everything is objects. We've just said that objects have values, so they have data. These data have some kind of attributes and methods. Okay? So when we say in Python, everything is objects, it means the objects that we have in Python, they have attributes and methods. Okay? So it doesn't matter whether we are dealing with the simple types, the immutable types. It doesn't matter. Or we're dealing with the complex type, the dictionary, the list, and the likes, those and the mutable types. Okay, it doesn't matter. They all have attributes and methods. Okay, so if we do, let's go back to x is equals to 10, for instance. Okay, so here, type of x is the int object, integer object. Okay, we can call some kind of methods on our integer if we like. Remember, this is simple type, it's immutable. Python, and because it's objects, Python allows us to call methods on our integer. So we could do something like x dot. Okay, so we use the dot notation to call methods on objects. So at this point, x is pointing to an integer object, which is why we're using x dot. Okay, so x is some kind of label now. Okay, so we can do x dot as integer, ratio. Okay, let's see what we get. Good. Now we get a tuple. Okay, we get a tuple here. A tuple is it's also a simple type. It's immutable. Okay, so what this is doing is it's taking our integer value, our integer object here, is converting into a tuple. Okay, so it's like a tuple is like a ratio. So this is the numerator, this is the denominator. Okay, so it's taking our integer object, taking it to its ratio equivalent. Okay, we can also do x dot bit count. Bit count, what am I doing? Bit count. Let's see, we get 2. Why are we getting 2? Okay, so it turns out that the bit count, it returns the number of ones in the binary representation of the absolute value of the integer. So what is going on here is bit count is converting our 10 objects integer, which was in decimal, it's converting it to binary. And in binary, 10 is 1010. So it has 2 ones. So it has 4 bits, 2 ones. Okay, 2 ones. So that's giving us 2. Okay, to establish what I'm trying to say, we can do x dot bit. I'm going to do bit length. Let's see what we get. Okay, this is 4. So 10 is 1010, 4 bits. Okay, we can also, okay, like we said, we can point variables around to objects. We can point variables to different objects. So if I do x equals to hello, now if I do x, I get hello. Okay, x is now pointing to hello. So I can do x dot upper, for instance. What do we get? Okay, so hopper is a method called on our object hello. Okay, so it's converting that object string, that string object, it's converting it to uppercase letter. We can also do x dot capitalize. I think this capitalize the first what is it called, the first letter. Okay, so this capitalize the first letter. Okay, there are other things we can play around with. Okay, we can also point x to an array. 1, 2, no, let's do something else. 2, 4, 6. Okay. Sure enough, when we do hex, we do this. Okay. Then we can do x dot append like that. Oh, oh, sorry. So this is x dot append. I'm supposed to add something. X. Supposed to take an argument. So now we do hex. Okay, so with that we have 2, 4, 6, 8. In the other, okay, if I do x is equals to 5, for instance. Okay, now I'm pointing x to 5. Okay, if I do, the other time we were doing x dot x dot as integer ratio. Is that what we did the other time? X dot as integer ratio. Okay, let's do as integer ratio. Okay, so this is what we have. We say it converts this tuple. Okay, which is this is numerator, this is denominator. What I want to show you is I'm trying to I want to draw this idea. I want to draw this idea of everything in Python is object. So what I'm trying to say is, look at this method as integer ratio. If I do type as integer ratio, I don't know if this works. Let's go. Okay, so as integer ratio is not defined. Come in if I do type. No, as integer ratio. Does that work? It's still not defined. I thought I could. Oh, okay. What if I do type dot as integer? No. Come here. As integer ratio. Does this work? Oh, this is invalid syntax. What I'm trying to do is I'm trying to establish the idea that everything in Python is object. So I don't know why this is not working. If I do x is equals to 4.6. Okay. Sure enough, x is 4.6. Okay. Now if I do x dot, okay, I think the issue I was having the other time is I didn't actually, oh, pardon me, please. I didn't actually write the full program. So if I did, what I was supposed to do is when we did, okay, see, if I do type, so it was telling me the other time that that method is undefined. Indeed, it was undefined. So I could do, what I should have done is x dot is integer. Now I'm going from float now. X dot is integer. Does this work? Oh, see, this work. Built-in function or method. Let me draw this in. I can do x is equals to 10 again, like we did the other time. So we say x 10. Okay. Now, if we do x dot as integer ratio, okay, so this is giving us a tuple. Okay. Now, what I'm trying to say is I can even devise the type of this method call on this object by doing type, then x dot as integer ratio. Okay. See, it's saying built-in function or method. So this is for me, this what I was trying to accomplish that I failed before now was to try to drill in the idea that everything in Python is objects. Okay. Uh, if you want to learn more about how these variables work, I have an article on my website. So you can go to www.singulateacademy.com.ng. Uh, so, okay, so you can go to this website and then you can scroll down to, no, just go to the blog section, go to the blog page, okay? On the blog page, you can just scroll down. See here, I have a Python variables and objects. So you can just click on these and then you can read. It's just 4 minutes read. It's not that long. Okay, so you can read about this to learn more about Python variables. Okay, um, the next time we're going to be talking about data types, the Python, the Python types, object types, the mutable, the immutable types. So I'm going to stop for now. If you have any question, please feel free to leave a comment down below. Uh, please subscribe, like, and share. I'll see you guys the next time. Thanks for watching.